All right, we're going to try a little something new. We're going to try my document camera for this lesson since my mouse is kind of freaking out. So what we're going to do for these next few lessons is we are going to have some factoring for a warm-up. So I'm going to do one with you, maybe two, and then I want you to practice. So this one's on there twice, so we're going to cross that one out. So this is factoring the greatest common factor out. So the biggest thing I can pull out of 3 and 12 is a 3. The biggest or the most of the x's I can take out would be an x squared because they both have at least 2. So remember, you put the greatest common factor in front and then you divide both of these. So we would wind up with x squared plus, and then divide this by the 3x squared to get 4. Okay, and then you look to see, can you factor this? And nope, can't factor that anymore, so you're done. All right, try the next few on your own, and then you can check. Hint on number 2, you're going to pull out just a number. So think about the number you could divide each of those by. It comes out front. It's kind of like undistributing. So pull out a 4, and you'd have x plus 4 left. On this next one, what can you pull out of each of those? Well, you can divide out a 2xy. So you wind up with a 3. You wind up with a 2, and simplify again. 3 minus 2 is 1, and 1 times this is just this. And if you notice, these are both like terms, so technically you could just take 6 minus 4 and keep the xy, and you get 2xy. All right, if you haven't tried 5 or 6, I want you to pause the video now. Try 5 and 6, again, looking at each thing, each term, and figure out what can you divide out of each of them that's the same number and or variables. So for this next one, we look to see if they all have at least one x. Yep, they all actually have at least 2 x's, so we should have an x squared. Then we look at the numbers, 3, 1, and 12. So there's no numbers, really, it's just that x squared we can divide out. So taking an x squared out of each of these and dividing it out, we would have this left. Okay, and then technically we would go farther and continue factoring, but for now I'm just going to leave that there and move on to the next one. Pulling out a 2, and we would wind up with a 2x cubed plus 4x minus, now we're dividing the 2 by a 2, so we need to hold that place with a 1. Anytime you divide by that same thing, hold that place with a 1. So again, always look to see if you can factor. Like on number 5 you can, but we haven't really talked about that method yet. So we're going to leave it like that for now. Let's move on to quadratics. So we have seen what a quadratic looks like. It's x squared, that's what it is. This is in standard form, which you've heard of before too. Standard form. And the highest degree, if it's in standard form, is the power of 2. So that's what makes this a quadratic. What would happen if the a was a 0, if there was a 0 in front here? So it would be 0x squared, and that would mean that there is no x squared, so it would not be a quadratic. Not a quadratic. So the parent function is x squared, as we can see down here, and then we have a table so that we can actually go ahead and just graph this parent function. So these are all just the values of x listed here, and we're going to actually plug them in. So negative 5 squared, I'm leaving off the f of for these first few. And negative 3 squared, and what do we get? So this is my ordered pair. What do I get when I plug negative 5 in for x? I get 25, positive 25 for the function when I plug that in. The next one, negative 4, when I plug that in, I get positive 16. I get, when I plug in negative 3, I get 9. When I plugged in negative 2 squared is 4, so negative 2, 4. Here, negative 1, we get positive 1, 0, we get 0, and just continuing on, plugging in those numbers, plugging it into x squared. So 3 squared, 4 squared, 5 squared, and so forth. Now we're going to go ahead and graph these points. Notice that our values for our y are the perfect squares because we squared it. So you do want to memorize 1, 4, 9, 16, 25, 36, all those perfect squares. You want to have memorized. It will help you tremendously. So let's go ahead and graph these starting at 0, 0 for my vertex point in the middle there, then 1, 1, then 2, 4, then 3, 9. So notice I'm just graphing up based on those perfect squares. So 1, 4, 9, then 16, then 30, then 25, then 36. And then I'm going to do the same thing on the other side for my coordinates here, negative 1, 1, negative 2, 4. And then I should start to see, 9, not 10, and then 16, and then 25. So now I'm going to go ahead and draw my U. And there is my x squared parent function. So this graph is a U shape. Its domain, what are all the x values? Well, we have all these values over here, all the way over here. So we have both negative and positive. So we have all real numbers. You can write that. Or you can use the symbols negative infinity, comma infinity to represent from the negative infinity side all the way to the positives. Our range is our y values. So looking from here, it looks like we're going up, but do we have any down here? No. So 0 is the lowest y value. So that means we're going from 0 to positive infinity. And the vertex point right here is 0, 0. All right, so let's go ahead and practice graphing these. The more you practice, the easier it gets. So remember your perfect squares, 1, 4, 9, 16. You're going to start at 0, 0 for our vertex point. 1 is going to be at 1. 2 is going to be at 4. 3 is going to be at 9. So that's your 4, 9. Next, 4 is going to be at 16. 5 is going to be at 25. And you're just squaring. 6 is going to be at 36. And 7, squaring 7 would be 49. So now that we have all those points, we just mirror them onto the other side. So negative 1 squared is 1. Negative 2 squared is 4. Negative 3 squared is 9. 16, 25, 36, and 49. And then we can draw our U shape. So getting this parent function, those points memorized is going to help you tremendously. So we've already been dealing with absolute value, which was pretty easy because it just had a slope of 1. Well, now this one changes. That slope is not a continuous slope that's the same. So start you off on this next one, but I really want you to try 3 and 4 on your own. So think about 1 squared is 1, so 1, 1. We're always going to start at 0, 0 for our parent function because it hasn't changed. So always vertex is at 0, 0. 1, 1, 2, 4. So think 4, 9, 16, 25, 36. Again, think about those numbers squared, taken times themselves. So try and finish this graph and then check. So pause the video if you haven't. Try it and then hit play. All right, let's check. Here we go. Should look like this. So we've got it at 1, 1, 2, 4, 3, 9, 4, 16, and 5, 25. And then the only two we can fit over here is negative 1, 1 and negative 2, 4. All right, so pause, try the next two, and then check. Same points that you did on these first two, just graphing the parent function. Oh. All right, let's check. So 0, 0 is where you should have started. Ignore this little point there. 0, 0, 1, 1, 2, 4, 3, 9, and then the other side, negative 1, 1, negative 2, 4, negative 4, 16, negative 5, 25. So those squared. And then the next one, 0, 0, 1, 1, 2, 4, 3, 9, and then mirror on the other side. So definitely want to practice those because that will help you tremendously. All right, let's take a look at the next page. What we're going to do is fill in our table. So we are going to figure out first what the starting value is going to be. So the x value to start is going to be this formula here, and then you're actually going to use this a little later on as well. Negative b over 2a. So our first step is going to be the label a, b, and c. If it's in standard form, it's already in order. A would be the 1, b would be negative 4, and c would be positive 3. So we're going to use negative b over 2a. So negative, and then plug in the b, negative 4. Over 2 times a, which is 1. So negative and negative makes a positive, and 4 divided by 2 is 2. So I'm going to put that in that bolded section here. That's going to be our starting value, and we're just going to go down from there and up from there. That will help us graph it nicely. So we're going to plug these values in for x, both x's, and then we're going to come up with our ordered pair in order to graph it. So 0 squared minus 4 times 0 plus 3, and so forth, and just filling all those values in for x. And you just did this in section 3.3, kind of making that table and plugging those values in. Remember order of operations, so we were going to want to do the exponent first, then multiplication, then our addition. So for this first one, 0 squared 0, negative 4 times 0 is 0, so we just have a plus 3. So 3 is our solution for our f of x, or our y, our output. Next one is 1 minus 4 plus 3, so that's 0. And again, take it one step at a time. Next one is 4 minus 8 plus 3, so that's negative 1. And you want to be really careful as you're adding these. Use a calculator if you need to. 9 minus 12, so do the squaring first. Do the multiplication here, so 9 minus 12 plus 3, and that gives you 0. And then our x value, so this is our x value, and then the solution here is our y value, our output. So 4 comma, and 16 minus 16 plus 3 is 3. All right, so let's go ahead and graph this. So down here, we're going to use these points that we got up here to graph it. So 0, 3, 0, 3, and then 1, 0, and then 2, negative 1, and then 3, 0, and then 4, 3. And we have our U shape. And there it is, kind of. All right, go ahead and do the next one on your own. Pause the video, and you're going to start with that negative b over 2a. So I'll get you started with that part. A is negative 1, b is 2, c is 8. So negative b over 2 times a. So that would be negative 2 over negative 2. So you're going to start with 1. 1 right here. Now you should have 0, negative 1, and then 2 and 3. So just kind of keeping that 1 in the middle there balanced, and then the other 2 just going up from there and then down from there. So now plug these values in to your function and then graph it. So pause the video, try that on your own, and then check when you're ready. All right, and here is what you should have for your table of values. Negative 1, 5, 0, 8, 1, 9, 2, 8, and 3, 5. And then here's your graph. It should look like that. All right. So at the bottom, let's go ahead and talk about the vertex of a parabola. That is the lowest or highest, depends